aspect of consciousness as experience. So we experience colors, we experience shapes, we experience pain, we experience emotion, and so on. And the function of consciousness. So we are conscious, and then we are able to do something. For example, if I see the red color, normally I can stop my car. From the point of view of conscious AI system, there are two aspects. So to study consciousness from the point of view of AI. One aspect is mostly related to the capability of replicate some aspect of biological consciousness in robots in order to build hopefully better robots. So we study neuroscience, we study philosophy, we study cognitive science in order to define models of consciousness that implemented in our robot allows us to have some capabilities of our consciousness. But on the other side, we can use our robot in order to better understand what is consciousness. So robots and AI systems may be used, may be employed in order to better understand what is consciousness. So it is a tool that may be used for study. So from the engineering point of view, we are mostly interested in building better robots. But neuroscientists, even philosophers and psychologists are more interested to use robots or AI systems in order to better understand what does it mean to be conscious. Of course, there are problems in being conscious, as Dilbert says. What is like to have no consciousness? Hopefully, a robot are not conscious. But if you are conscious, how it is like to be totally unimportant. So the feelings, our feelings, obviously gives us some problems. So it's not, we don't know if it is better or not to be conscious. And so a typical question is, why do we want to be consciousness to machines? So why do we want to build conscious machines? One aspect is that all intelligent systems, all intelligent beings are conscious. So from an evolutionary point of view, it seems that to be conscious should be a sort of advantage, because if you weren't an advantage, we were not conscious. So there should be something to be conscious. There is a kind of utility to be conscious from an evolutionary point of view. Possibly, the fact that we are conscious allows us to give some sort of adaptation. So it is more easy for us to adapt to the changing environment in our lifetime. Considering the typical phylogenetic adaptations of lower level animals or systems like bacteria and so on, their adaptation is in several needs. They need several generations in order to be to adapt to the changing environment. While conscious animals like us or like primates or mammals and so on we are able to adapt to changing environment in our lifetime. So we are able, possibly, all the conscious animals and humans are able to adapt in our lifetime, to adapt to changing environment in our lifetimes. Another aspect that could be useful in order to be conscious is the capability to cope with unpredictable events. So it is typical for us to have some sort of daily routines, and so even in our everyday life, we experience the fact that normally we are not so much conscious, but we became conscious when there is something unexpected. Think about driving a car, for example. When we drive a car, we have normally we have low level of consciousness. And sometimes we are totally unconscious, so we don't know how we reached our home, for example, from the office. While when there is something unexpected that happens, then we are in full consciousness, because we have to cope with unpredictable. So possibly consciousness allows us to cope with unpredictable events. Another possibility for the use for being another topic related to consciousness is the fact that today there are many discussions in the literature, and not only in the literature, even in from the political decisions, to building some kind of ethical AI. So there is a problem of ethics in AI. Possibly we need some sort of consciousness in order to build ethical robots, because some philosopher says that in order to act in an ethical way, yes, there are the rules, there are the regulations, and so on. We have to abide to the rules, to the laws, to the regulation. But in the end, we need to understand what does it mean to suffer, for example. What does it mean to act in a just way, in a correct way, or in an unjust way? So we need to be empathic in some sense in order to know what is right or what is wrong, because it's not so easy to understand what is from the law, from the laws, what is the right way to be. Those are obviously philosophical aspects that, but mostly some people say that we need some sort of consciousness in order to have an ethical robot or an ethical AI. Okay, let me allow you to describe some sort of history in conscious AI system or machine consciousness. The first occurrence that I found in my search on the term machine consciousness is in this book that I found. This book is named The Cybernetics Machine. The author is nameless, I don't know who it is. This book has been published in 1962, and there are second edition in 1967, and has been translated in 1970. I was able to find the English edition in 1970, and in 1970, this book, there was a subject which was artificial consciousness. So, as far as I was able to find, the first occurrence of the term artificial consciousness was from this book, from this author from Budapest. Let's consider that the term cybernetics was mostly used until some time, was mostly used from the scholars from the East Europe, from the Russian and countries from the East Europe. It is to be noticed that there is artificial consciousness in the subject index, and there is no artificial intelligence. So it seems that artificial intelligence was a term created after artificial consciousness. Okay, another book in 1989, authored by a philosopher, Leonard Engel, on how to build a conscious machine. It is a philosopher point of view, how to build a conscious machine. But the modern way of the modern framework of consciousness was in 1992, where Igor Alexander is a famous colleague in a neural system from the Imperial College of London, in 1992 proposed a paper in a conference, in a neural network conference, ICANN, which is still today. I think that there is the ICANN conference. It is a neural network conference. Proposed in his lecture, proposed how to capture consciousness in neural systems. I was so lucky to be present I was in that conference in Brighton, and I was surprised because in my life it was the first time that I heard the term consciousness from an engineering point of view. So studied from an engineering point of view and not from a philosophical point. Very briefly, in 2001, in a meeting called the Spring Harbor, there was a symposium And in the final report written by Christoph Koch, which is an eminent neuroscientist, and the conclusion of this meeting was that we know of no fundamental law or principle operating in this universe that forbids the existence of subjective feelings in artifact designed or evolved by humans. So the important aspect is that there are no one found some kind of principle or law or whatever that forbids the building of subconscious artifacts. So this is true still today. The problems related, the interests in machine consciousness resurrected in these days because, of course, of large language models. A typical question was even in journals: could a large language model be conscious? So, is ChatGPT conscious? And last summer there was a paper by David Chalmers, which is an eminent philosopher in this field, that asked these questions. And he says essentially that a large language model, according to his opinion, is not conscious. Similar, this is a philosophical paper. Even in this summer, there is a famous paper in arXiv written by eminent scientists, including, for example, Joshua Bengio, which is one of the godfathers of neural network, of the new AI, that analyzed from a scientific point of view the problem of artificial consciousness. Essentially, the methodology of this paper is very interesting because these authors took into account the most eminent, the most relevant theories of consciousness from the neuroscience, and they asked what they analyzed all these theories, the recurrent processing theory, global workspace theory, and so on, and they asked what this theory say to artificial intelligence. So if you want to build a conscious AI system according to all these theories, what this conscious AI system should be? So there are several questions, several elements that should be owned by an AI system in order to abide to these computational theories. According to this group of eminent authors, and even according to David Chalmers, the current large language models are not conscious, essentially because from a structural point of view, they don't have this, they don't abide to these, they don't allow to these, to all these requirements. So they may seem to be conscious, but they are effectively not. Those are some commercial. Those are some books that in some sense, I was the editor of. I am the editor-in-chief of this journal of artificial intelligence and consciousness, published by World Scientific. Recently, I collected the most important papers from this journal to this book. And there is also this special issue of Frontiers in Robotics and AI, which is open access, where I was one of the editor with my colleague Angelo Cangelosi, Giorgio Metta, which is the head of IIT, and Selmer Brinshaw, which is a colleague from New York. So in this presentation, I will try to allow you to introduce you to some of the theories, which are some I choose some theories that have some sort of a computational counterpart. So they could be potentially implemented in a robot or in an AI system. Of course, each of these theories capture some aspects of consciousness. There is still today, there is no single theory that explains everything is consciousness. So it is like the famous novel of the blind scientists that try to capture what is an elephant, but only touching a part of the elephant. So this is more or less the same problem. So each one of these theories captures some aspect of the problem of consciousness, but there is no theory that captures the full complexity of consciousness. Okay, one of these theories is the introspection or monitoring model. So the idea is that our brain is made up by several layers. There are the low-level layers that are mostly related to input-output, to the stimulus, to process our stimulus and to act in the world. There are high-level modules that are mostly related to the deliberative planning, reasoning, and so on. There is an higher level which is related to our consciousness. So essentially, according to this theory, the higher level of our brain are related to consciousness. An implementation all time in the 18th, many years ago, Richard Weirach wrote this paper, which is most important in artificial intelligence, prolegomena to a theory of mechanized formal reasoning, that proposed a system named FOL, which is first of logic. And this system was made up by essentially is a logical reasoner. So there is a logic part. Then there is a first order logic that tries to understand what happens in the world. So there are facts in the world, and the system was able to understand what is happening in the world according to the first order logic. But together with the logic, this system was there was also a simulation structure. So when the logical system was not able to understand what's happening in the world, was not able to reason to fact in the world, there was a simulation structure that tried to simulate this phenomena. So, for example, the system is reasoning about a billiard ball. For example, what happens in a billiard table, considering the balls that bump and so on and so forth. In this case, if the system is not able to reason according to logic to what happens in the billiard pool, there was a simulation structure, so a simulator of the billiard, of the ball, and so on. So the system started a kind of simulation in order to understand what is happening. So there is the logical reasoning system and a simulation structure. FOL is interesting because there was meta-FOL. So the simulation structure is the system itself. So in this case, you see that there is the metalogic aspect and the simulation of the system itself. So the system was as a model of itself. So the system was able to reason about itself. So there was the logical aspect of the system that reason about the system itself. In case the system was not able to find the interesting fact, the system starts a kind of simulation of itself in order to understand what is the behavior of the system. So, and this is a kind of meta-reasoning system, which is so the system was able to reflect about itself. It is a typical aspect of consciousness, so the capability of reflects about itself. So it seems that we have a model of ourselves, and we're able to reason about ourselves. Okay, there are many aspects of this, many versions of this kind of model. Even Marvin Minsky, which is one of the fathers of the artificial intelligence, proposed a kind of the emotion machine, which is named. It is a system with several layers. From the low layers are mostly related to instinctive reaction and so on, while the higher level are able to reason about the layers, about the other layers, in order to critique and analyze what happened in the first layers. So it is a system, also in this case, that is able to reason about itself. Let's say, from a more formal point of view, John McCarthy, which is another father of another father of artificial intelligence, proposed a kind of logical system. I cannot enter into the details in this system. A kind of logical system, a logical formal system, which is named mental situation calculus. A mental situation calculus was a system which is able to reason about itself from a logical point of view. There is a group of logics, even today, there is a group of logics that try to capture consciousness by using the formalism of logic. One of the most important, I skip to today, one of the most important theories in consciousness, this is a theory from neuroscience, which is the integrated information theory, was proposed initially by Giulio Tononi, which is a neuroscientist from the University of in Wisconsin. According to Giulio Tononi, the IIT, the Information Integration Theory, the main aspect of consciousness is related to the capability of integrate information. So I'm looking at you, but I don't see the colors and the shapes and the, I don't know. I see my conscious perception is a perception of integration. I see in the same scene, I see the color, the shape, the odor, and so on, and the movements. So we are able to integrate many kinds of information, even if all this information is processed from different parts of our brain. We know that there is a part of the brain that processes the contour of the system, the edges of the object. There are other parts of our brain that process the colors, the movement, the shapes, and so on. But when we perceive something in an integrated way. So Giulio Tononi and his co-workers proposed a mathematical measure of integration of the information, So considering, for example, a system. A system is integrated if I perturb one part of the system, if I perturb the A part of the system, and there is something that happens in the B part of the system. So if I perturb something and there is, if I perturb A and there is something that happens to B, it means that the two parts are integrated. So there are two possibilities. One possibility is this one. There is a real integration. And this is no integration. So if I perturb A, nothing happens to B. So Giulio Tononi proposed a kind of cutting the system in many subparts in order to find the subsystem which is able to integrate information. And he proposed a measure, which is phi. It is a measure of integration in a system. It is the mathematical theory, which is in the theory of Tononi is not trivial. Anyway, he proposed, and this is interesting because Giulio Massimini, which is a neuroscientist from the University of the Polyclinic in Milan, studied this kind of measure in human brains, and he found that the region of our brains that have a high level of phi, of this kind of measure integration, are the typical regions where neuroscientists hypothesize that there is the locus of consciousness. So this is interesting. It seems that our brain is capable of integrating information. They use typically, in order to have to allow this kind of perturbation, they use a kind of system which has some gives us a sort of electromagnetic field in the brain that in some sense anesthesize a part of the brain. So it is it's like giving a kind of touch in a brain and see what happens. I tried. It is a very strange feeling because I was not able to talk, for example, for a few minutes, of course. Okay. The idea, yeah, for some, because there is a kind of you anesthesize for some time some part of the brain. It is a magnetic field. Era analogo di una botta in testa. There is a kind of magnetic field that anesthesize for some minutes the parts of the brain and see what happens in the rest of the brain. So to see which areas of the brain are linked to other areas, and the areas which are more which are connected to all the other areas, so that are the areas which are mostly which are the candidates for being the locus of consciousness because they are able to integrate information. From the point of view of machine consciousness, so building robot, this is essentially interesting because, according to Tononi, we should be able to build entities, systems that are able to integrate information. According to the last version of the Tononi theory, the computer are not able to integrate information according to the theory. Essentially because we work in bits, so typically a computer is based on the idea of divided in pairs. So typically in our software we subdivide our program in several parts and so on. While we need some sort of mostly analogical computing, so systems that are able to effectively integrate information. It is longly debated, of course, this kind of theory. There are some attempts to build computer systems that use a neural network, for example, that are able to build to integrate information. Of course, it is a field, it's a research field. There is a problem because the problem is that this summer a group of scientists, a large group of scientists, wrote a letter according to which, according to these scientists, the integration information theory, according to them, is pseudoscience. So the idea, they contested these findings of Giulio Tononi. They say it is a kind of pseudoscience. It's a huge debate. And many people say that it's a political problem because the group of Giulio Tononi in the United States received a lot of money for too much money for this research, and all these people receive nothing. So they wrote this letter in order to fight against Tononi. Anyway, anyway, the integrated information theory is one of the main theories from the neuroscience point of view related to consciousness. The other theory, which is the other main theory, is what is named the global workspace theory. According to the global workspace theory, the idea is that in our brain we have several. I am a computer scientist, so I describe this theory from a computer science point of view. There are many processes that are in parallel in an unconscious way. So there are as many processes in a computer. For some reasons, one of these processes win the competition against the other process and gain access to a global workspace. So we have in our brain a global workspace. There are many processes that are unconscious. For example, I'm looking to you and I'm talking to you, but there are many other processes in my brain that allows, for example, from the lateral view, and I'm feeling the chair and so on and so forth. But in this moment, I'm talking to you, so the main processes that gain competition in my brain is the process that allows me to talk to you. If something happens unexpectedly from some people that enter on the door, another process, for example, the process that the unconscious process that is tracking the door, for example, that might be a process in my brain that is checking the door. If there is one person that enters the door, then that process gain competition in our brain. So this is essentially in essence the global workspace theories. We have several unconscious processors that compete in order to access the global workspace, in order to recruit more processors. When there is a winning processor, this winning processor recruit other resources in our brain. So, as you may understand, it's quite easy to. There are many implementations of this theory because essentially it is a computational theory. It's quite easy to implement. The first implementation was named LIDA from the group of Sam Franklin, which is recently died in Memphis University, and Sam Franklin built a kind of LIDA version of the global workspace theory. The LIDA it is named as a kind of cognitive architecture. You may download this architecture, you may try, and you may use it. Another model for skip to another, I will give you an overview of some of this theory, is the theory of internal model. According to this theory, an intelligent system has an internal model of itself, an internal model of the external world. So we have two kinds of action in our brain. I perform an action in the real world, so I push my glasses, but I can also have an internal simulation. So I might think I have a model of myself, I have a model of my glasses, so I might think to push my glasses in my brain. So I may imagine to push the glass in my brain. So I am able to reconstruct the external world, to reconstruct myself in my brain, and so I can simulate the operations in my brain. So there is an agent that interacts in the external world, but the agent has a model of itself and a model of the external world. So while the agent interacts in the external world, in the mind of the actor, let's say, there is a simulation between the external world internal to the agent and the model of itself. An implementation of this theory is a first implementation of this theory was due to Owen Holland, which is a colleague at the University of Exeter, that built this kind of robot, Ecce robot, Ecce robot or Ecce robot. According to Owen Holland, we should try to study robots that are the most similar possible to us. In order to have an artificial consciousness which is similar to our consciousness, we should build some kind of robots that are most similar to us. So he built this kind of strange robots made up by plastics and so on and so forth. It is quite impressive because it seems like a skeleton, but it's homemade essentially. It is the result of several European projects. They were able to build this kind of strange robot made up by tendons, made up by motors, and so on. You may understand that it's quite difficult to control this kind of robot because there are several degrees of freedom, several. So, thousands of degrees of freedoms. And then they use an internal model in order to control the robot. So they have a simulator, an internal simulator of the robot. The robot starts, the simulator of the robot starts moving in a casual way, like it is similar to what happens in children. This kind of behavior is named motor bubbling. So just like the child starts to talk in some sense in a casual way by babbling, so by emitting casual sounds. Even in this case, this robot starts to move in a casual way. Then when the robot finds some kind of control, so it's able to control its degrees of freedom, then it's learned how to control this kind of degree of freedom. So you can see what happens. The robot is trying to control itself. This is the simulation of the camera. So this is an example. This is an example of control where the system, where the robot is too much complicated to write the control equation for a robot of thousands of degrees of freedom. The robot starts learning to control itself. This is a powerful idea, and there are several examples. Another example is by the group of Odd Lipson from the University of Columbia University. Odd Lipson tried more or less the same principle in order to control a kind of starfish robot. You can see this is the starfish that built. And the starfish tries to build a model of itself by moving in a casual way, in a random way, and then it sees that if the movement in the internal model of the robot matches the movement in the external aspects, in the real world. So the system, in this case, the robot is able to build a 3D model of itself. Then when the system is able to, as a model of itself, is able to use this model in order to work, for example. So the system is starting to work in simulation, and then it starts to work in the reality. It's a little bit disgusting anyway. Okay, and this is a kind of resilient machine because you can break one part of this robot. Let's just consider we damage this robot. We can break a leg of this robot. Then the robot should be able to rebuild a model of itself. Once the robot is able to build a model of itself, to update a model of itself, then it starts to work in some ways. Recently, they applied the group of Lipson applied a similar system by considering a robotic. Let's see if it happens. Okay. A robotic arm that look itself in the mirror, essentially. So there are several cameras. It's a long movie. Okay, there are several cameras, and the robot is able to build a model of itself by looking itself in the mirror. So there is no real mirror, but there are several cameras. Okay, there are several cameras, and the robot starts to move in a casual way, in a random way, and then the robot is able to build a model of itself. This is a similar aspect. We use the same aspects, aspects in the CISA robot project. The CISA robot project was a robot was able to offer guided tours at the Archaeological Museum in Agrigento, which is south of Italy. And even in this case, we used a mobile robot. The mobile robot was able to build a model of itself and a model of the museum in order to offer guided tours in the Museum of Agrigento. This was made in 2004, 2005, so many years ago. So the visitors, the typical visitor of the museum, look at the robot. It was in some sense surprising because at that time it was not so easy, not so common to find and in this case, the robot generate a kind of prediction of the external world. This is the internal model of the museum, and this is the real camera 2004 technology. This is the real cameras of the robot. This is the internal robot, and the robot tries to match the two, the internal view with the real external view. This is the principle of this. Recently, this case study was considered, was registered as a kind of use cases by the ISO standard. So the robot consciousness, so the case of our case of Cisa robot was considered a use case of robot consciousness by the IEEE. And you find this one in the official use case of the ISO. I'm finishing with by presenting our most recent work, which is the work related to inner speech. So one aspect of consciousness, as I said before, is the capability of look at itself, and many of us as a kind of internal monologue. So talk to many of us talk to ourselves. This is an atypical aspect of consciousness because we talk to ourselves, so we imagine ourselves and we talk to ourselves. This is made up, for example, in order to rehearsal, when I have to prepare an exam, or when I'm reflecting, when I'm thinking. Typically, many of us, not all of us, many of us typically have a kind of internal voice, an internal monologue that we talk to ourselves. Then we, together with some with some psychologists, which is expert in this field, we proposed a kind of system, a kind of cognitive architecture, in order to capture some aspect of these effects, the capability to think about us, and we are able, we are able to hear what the robot is thinking. Let's say we are too young, but there is a famous movie where the actor is Mel Gibson. The movie was named What Women Want. Sometime I suggest you to find it some way. The character of Mel Gibson was able, because of a thunder or whatever, a kind of accident, to hear the inner speech, to hear the thinking, the thought of the women. So it was a nice movie. So we imagined to hear the inner speech, of. We implemented this architecture in using ROS in a paper, and I will show you some movies.
At a table. Human requires to robot to provide him utensils. The goal of this demo is to show the differences in human-robot interaction when the robot talks and does not talk to itself. In the first part of experimental session, the robot does not dialogue with itself. The human requires to it to pick the knife.
Okay, I'm picking on the glass. Pepper, can you pick out the knife, please?
The typical robot's routines run, and the knife is provided to the partner.
This is the typical interaction.
In the second part of experimental session, the robot inner speech starts. The human requires the same object.
Can you pick out the knife, please?
Inner speech is triggered by the knowledge of a property of the knife. The robot retrieves from its knowledge base that the knife is dangerous and sharp. Robot exposes its concerns to human.
Be careful. They'll learn how to take it.
By hearing the robot inner voice, the human knows in advance what the robot will tell him. The robot and dialogue enabled both human and robot to focus attention on a possible problem, and the human trust could grow.
So in this case, the robot,
Thanks for your
the
attention.
person, the user, by hearing the voice of the inner voice of the robot, is able to take into account the fact that the knife might be dangerous and so on. A typical situation where the inner speech triggers is in case of conflict. It's typical when we have some kind of conflict, then we start to talk to ourselves. So in this case, we tried our system by considering a very simple dilemma, in the sense that the robot have to set up a table, and the user give a command which does not match with the typical etiquette in order how to set up the table, the knife on the right, the spoon on the left, and so on. Which is a typical trigger for the ethical dilemma, is a typical trigger for inner speech.
Human and robot are setting the table. Human gives to robot instructions for placing the utensils on the table. The table has to be set according to the etiquette rules. Both human and robot know that the schema to follow for placing utensils on the table is the informal schema. At the start of the interaction, some utensils are already placed on the table. The robot knows the context. Human will require to the robot to place an utensil on a wrong location according to the etiquette schema. Robot detects the conflict situation, and it has to solve it in some way. The goal of this demo is to show how inner speech solves a conflict.
They're not stable. Maybe things wrong. The patient may be got confused. I want to be sure, and I'm asking him again. Look, I knew the position is not correct because it contravenes the etiquette. So, do you want me to do it anyway?
Yes, sure, Patrick.
How come?
I just want to set the table according to the etiquette.
Okay, I understand. This situation upsets me. I never break the rules, but I care for him. So I'm doing what he wants. I'm trying to place the object. I'm using my right arm to place the object.
In this case, the robot preferred to contravene the rule for fulfilling humans' wishes. However, human knows the conflict of the robot by hearing its inner voice, and he knows that the robot solved the conflict by preferring the human needs. As a result, the human's trust for robot could grow. Thanks for your attention.
So in this video, there was a very simple dilemma, but the inner speech of the robot allows the user to understand the dilemma. Oh, another aspect, we made several experiments, and to make a long story short, our find is that the robot with inner speech is perceived as more anthropomorphous with respect to robot without inner speech. And a typical situation where there is inner speech, where the inner speech is triggered, is in front of the mirror. So typically, many of us, when we are in front of a mirror, start a sort of inner speech. So we used the same system for inner speech in order to, we put the robot in front of a mirror and see if the robot is able to recognize itself by using the inner speech mechanism in order to recognize itself. So, so this is the experiment. It's the robot in front of the mirror, start with inner speech.
Is this robot like me? Yes, we are the same kind of robot. The robot I'm seeing is a pepper like me. The pepper robot I'm seeing in the mirror has a mask. Am I a mask? I want to touch my mouth for searching for the mouse. I will use my right arm grip. I will try to move it. The right arm grip is working. I have to move the right arm to the position of my mouth and moving my arm.
So the robot is reasoning about itself.
Here. The mask I'm seeing is mine. I have a mask. So, people think I'm a robot, and I know I'm a robot with a mask. It's the robot I'm seeing in the mirror. This robot is me. There are like a real robots here. Oh, yes.
So in this case, the robot look at itself in the mirrors. That there is a robot, and the robot wears a mask. He moves the arm and sees from the mirror that the robot with a mask. It controls that there are no similar robot next to him, and then it concludes that it is that the robot in front of the mirror is itself. And we discussed about anthropologists about these tests, and they told us that it is not real recognition similar to animals, because the recognition in animals and even in children is an immediate recognition. This is a kind of cognitive recognition because the robot reasons about itself. While when we look at ourselves in front of the mirror, we immediately recognize it ourselves. So we don't need to reason. Even animals, but only the only animals that are able to recognize themselves are the higher primates, are the chimpanzees and whatever. So it seems that only them are able to recognize themselves, not the other. Okay. Let me conclude saying that we have a very large media coverage about the inner speech, the robot with inner speech. I've been interviewed by the New York Times, by the New Scientist. There was an interview in the Communication, the ACM, and so on and so forth. But we also get in touch by a rapper, Mega Rain. Mega Rain is a rapper from Philadelphia, and he wrote a rap of our inner speech robot. And if you see, if you check in Apple Music or in other, you find Mega Rain, which is a rapper from Philadelphia.
Yo, this is Mega Ran, and this is Event Rap. Robot consciousness. Inner speech is the sound and expression of conscious thought to oneself in a coherent progression. It's usually linguistic, but I like to pose a question. Is subconscious thought possible in our robot-preferring way? But you question my faculties or you laugh at me. Let me explain what this has to be possible, or at the least worth exploring and how relevant. Data process provides empirical evidence. Yo, shout out to Chella and Peppertone, one of the first to note that machines do get in the zone. Like, when you talk to yourself, when you enter work or ponder if you're offered some help, robots do the same if you believe it, considering alternatives that lead to successful goal achievement. Like in a simple collaborative task, humans and robots connect in ways they never before have. In speech, before text to speech or speech to text, I would give my Teddy Ruxpin PE cassettes. Nowadays, we're in the future. Prognosis excellent. Machines being taught table etiquette. Yo, it's happening. Imagine learning from mistakes, improving all procedures at rapidly growing rates, and applying functions they didn't even know before. Man, technology, it continues to open doors. And I'm going to stop before we take it overboard, but I'll just say that I, for one, welcome our robot overlords. Robot consciousness. Yeah. Inner speech is the sound and expression of conscious thought to oneself in a coherent progression. Robot consciousness. I like to pose the question. Inner speech is the sound and expression of conscious thought to oneself in a coherent progression. Robot consciousness. I like to pose a question. Inner speech is the sound and expression of conscious thought to oneself in a coherent progression. Robot consciousness. I like to pose a question. Inner speech is the sound and expression of conscious thought to oneself in a coherent progression. Robot.
Okay, so my time is over. Thank you for. Thank you. Those are some of the people and the robots in my laboratories. There are colleagues, there are graduate students, there are students, and so on. So,
You have questions or comments? Curiosity? From home? From nobody?
Yeah, I just got a question. Hi, Antonio.
hi, Giancarlo.
So very nice speech. The last part is incredible, you know. Very nice rapping, you know. So I mean, I'm not from your area, but you know that I worked with multi-agent systems, so both from the methodological perspective, also from, you know, the middleware. Also, we implemented multi-agent systems. Now, you know, this is the usual question, because there was a boom in the AI area with the generative AI. Okay, specifically just to name, you know, ChatGPT. Okay, but it's not the only one. It's not the only one. Do you think it's possible to include the same mechanism, this inner speech, inside ChatGPT or inside a generative AI? Or, you know, the model is fully different. I know that, you know, it's pretty different. But you think that this could provide even, you know, more trust, you know, for people to include such kind of mechanism in ChatGPT or similar tools?
So thank you, Giancarlo, for this interesting question. Yes, I think that it is possible to include some kind of inner speech in the area in large language model, and some of my colleagues are working in this area, but not only. There is a paper which is completely unrelated to our research that proposed a similar problem, whether to include inner speech in large language model, essentially in situation where the large language model have to plan something, for example, in the generational plan, essentially. So if a large language, as you know, a large language model are also able to plan, to generate plans. Including these Google researchers showed that including a system of an internal system of similar to our internal speech, if they include in generational plans, for example, in order to reach for the robot to reach a place, to get some object and to have some mission in some sense, then the behavior of the system, the behavior of the robot is far way better than a system, that a large language model without inner speech. And consider also the fact that today there are the large action models at the last size. There was some systems that are not only related to word, language model of word, but also to action. So there are some systems that are proposed for systems similar to large language model, also able to act in the real world, or similar to a robot. So in this case, the inner speech was not only related to the thought of the robot, but also to the action of the robot. So I think that this is the next, it will be the next step for our for this kind of research.
Okay, thank you. If there are no other questions, we say goodbye to everybody and we close the session. Thank you to all the attendant, 30 people. Thank you.
Thank you.
And
Bye-bye. Ciao.
Thank you. Bye.
Thank you. Bye.
Thank you. Bye.
bye.
Thank you. Bye.